12.4b, which is finding segment lengths. And there is one theorem for this section, but that theorem looks 3 different ways depending on what you're working with. What you need to remember is the idea behind it, because if you can remember the rule that goes along with it, then it doesn't matter what the formulas are. You should be able to come up with your own formula every time, okay? So if you can remember the rule, you're in good shape. And I don't feel like it's a hard rule. Just have to pay attention a little bit. All right, I'm going to give you 3 circles, and we are going to lay out our rules here. Okay, the theorem says this. Just listen. I'm not going to write this out, just listen. For a given point and circle, the product, what does product mean? Multiplication, okay? The product of the lengths of the 2 segments from the point to the circle is constant along any line through the point and the circle, okay? So key things, thank you. Taylor, this is not for right now. The key thing to remember is you are dealing with a product, and it's always coming from the point where your lines meet. Okay, now that might happen inside the circle, so that's what this would look like. Our lines meet inside the circle. Here's my center, okay? That's not the center of the circle where they meet, but they do meet inside. If I give these lengths of A, B, C, and D, we said it's the product from the point to the circle on both lines. So that means from the point, okay, here's my point. From the point to the circle is a length of A. From the point to the circle, the other direction is a length of B. So we are multiplying A and B, okay? That will be constant, so we can set it equal to from the point to the circle, C, from the point to the circle times D. So A times B equals C times D. That's when it falls inside the circle. I feel like that's the one that most people get fairly quickly because it's just multiply the 2 that are on the same line, right? A times B, C times D. Where it gets a little hairier is when it looks like this. So now it falls outside the circle. Okay, but the thing is, the rule is the same. So if I give you X here and W here, and then Z and Y. I'm going to give you a second to draw that so you hear me as I explain this, because it's the same thing as what we did in the first one, but it's not going to look the same. The rule was from the point to the circle gets multiplied from the point to the other side of the circle, okay? So if we're starting at this point right here, okay, we're starting at the blue point. The distance to the circle here is how long? W, right? Okay. Then you go back to the point because it's got to be from the point to the circle. How long is it from that point to the other side of the circle? What? Someone said it. Is that you? How long is it from the point to the other point on the other end of the circle? X plus W, okay? Or I'm going to do it as W plus X because that's how the formula gets laid out in the book. I don't want to confuse people. So we're doing the same thing. We're multiplying from the point to the circle and from the point to the circle. It's just that now there's parentheses involved because that second segment is not just W or just X, it's W plus X, okay? That means on the other side, we're going from the point to the circle is how long? Y. And from that point to the other side of the circle is how long? Y plus Z. Okay, do you see how you're doing the same process? It's just looking different because of the point being outside versus being inside. Yes? Okay. Then this last one is a tangent. Apparently we didn't pick our, there we go. Okay, so for this one, now you have a tangent over here. Okay, so this is tangent. And this one's slightly different again because now we only have one segment, one variable on our segment. But it's still the same idea. So from the point to the circle is how long on the tangent side? From here to here. T, okay? But it has to be the product from the point to the circle. So it's T times T. In other words, when you have a tangent, you square it. So it's going to be T squared. And then your other segment, you do the same as we did in the last one. So that would be what? Y times what? Y plus Z. Okay? Those are your formulas. If you can use those three on the pictures that I'm going to show you, you're in really good shape. Let's do a few. All right, so example 1 looks like this. You have a circle and this setup. This is 6, 8, 7, and Y. Okay, so I want you to think through this. First of all, we drew 3 pictures to start. First, second, and third up here. Which picture is this representing? First, second, or third? The second one, right? It's that middle picture because our point is meeting outside of the circle. So we're going to go from the point to the circle is how long? 6 times what? 6 plus 8, or you could just call it 14 right now if you want, if you don't want to mess with the 6 plus 8 thing. But it is 6 times 6 plus 8. What's your right side going to be? 7 times 7 plus Y. Okay, so from the point to the circle got us 6. From the point to the other side of the circle got us 14 up top, right? Then on the bottom, from the point to the circle, got us 7. From that point to the other side of the circle, got us 7 plus Y. Now it's just algebra. Just simplify. So you're going to go 6 times, we got 14 is 84. So 84 on the left. And don't think you have to distribute that, right? Just plug it into your calculator. 6 times 14, or 6 parentheses, 6 plus 8. Keep it simple. Equals 7 times 7 plus Y. And again, you could distribute here, or you could divide by 7 here. I would divide by 7, but I feel like 90% of my classes distribute, so I'm going to distribute. But just know that if you like to do the division, okay? So if we distribute this, this is 49 plus 7Y. Take away the 49, and you get 35 equals 7Y, and then divide by 7, so Y is 5. Okay, so really it's a matter of can you set it up, because once you set it up, it is algebra at its finest. Okay? Questions on that? All right, what do you do with this one? Sorry, that's not pretty. This is 8, this is 16, and this is Z. The point meets outside, and you have a tangent. What do you do? The third picture. So we have to do what with that z? We have to square it, right? When there's a tangent, you square the tangent. So it's z equals what? 8 times 8 plus 16. Or you could just call it 24 right there. You don't have to put it in that format. So 8 times 24 is 192. So you get z squared equals 192. And then how do you solve for z? Square root it. So you get, oh, that is not what you get. Approximately, to the nearest tenth, it would be 13.9. Okay. Last one, and then if you have any other questions, I can give you more examples, but this way you at least get one of each. All right, let's say you have seven, 4.8, and I want to know how long is AB. Okay, so I want to know the length of that whole, it's actually a diameter. What is the length of the diameter? We don't know the full diameter right now, but if we call this x, we can solve for x to find the diameter, right? What would I do to solve for x here? So this is like that first picture, right? Inside, when it meets inside, what do you do? This is supposed to be the easy one. 7 times 7 equals what? Right, 4.8 times x. So you get 49 equals 4.8x. You divide by 4.8. So 49 divided by 4.8 comes out to 10.2 if we round. Okay, the question was, what's AB? You got to add those together. 4.8 plus 10.2. So you get, sorry, that's a decimal point, 15.0 if we're rounding to the nearest tenth. So AB is 15.0 units long. Okay. Give it to me in your own words. What's the rule that you follow on every one of these? Or you can give it to me in my words. I'm not saying you have to make it sound different than what I said. What are you doing every time? From the point where they intersect to the edge of the circle, right? So from the point to the circle times from the point to the circle on both sides. Questions on that? Okay, tomorrow morning I will be here at 7:30 if you want to come for a study session.